Hello, Math 2 students. Today we're going to learn how to solve quadratic equations by using the graphing method. But today we're going to use a graphing calculator. The high score. A kid playing the basketball shooting game at an arcade beats the previous high score on the final shot. The kid releases the final shot with 0.38 seconds left on the clock. One of the equations below describes this final shot. The height of the ball when it left the kid's hand was the same as the height of the hoop. Choice A, h of t equals negative 10t squared plus 3t. Choice B, h of t equals negative 3t squared plus 1.3t. And choice C, h of t equals negative 4t squared plus 2t. Which of those equations describe the shot that could have been the shot that set the high score? To solve this problem, I'm going to use the Desmos graphing calculator. So I go to desmos.com, I choose graphing calculator, and then I'm going to put in all three of my equations and graph them on the same graph and see what it looks like. My first equation is h of t equals negative 10t squared plus 3t. Remember, when you're typing the exponent into the Desmos calculator, there are two ways to do it. You can either use Shift 6, which is the caret key, to make the exponent, or you can go down to the keyboard key and use the a to the second power key, and that will give you your exponent. What do the variables mean in this problem? Well, the h stands for the height, and the t stands for the time. So this equation will tell us the height if we plug in a certain amount of time. And so in this problem, for our x-axis, we are going to label that with time. And for our y-axis, we're going to label that height. If you go to the Desmos calculator and you click on the wrench, it will let you add a label for the x-axis. So our x-axis is going to be time, and it will let you add a label for the y-axis. Our y-axis is going to be height. So we have our graph with our time and our height, but it seems like the scale of our graph isn't very useful for our problem. Since we know t is time, and time is always going to be a positive number, there's no negative time, I'm going to make my scale so that it's a lot easier for me to read. I think that looks pretty good right there. So for my first equation, answer choice A, the ball is at a height of 0. That's right when it leaves the kid's hand. And the ball goes higher and higher and higher on the y-axis until it reaches this point here. And then it comes back down until it reaches the same point that it was at when it left his hand. And in the problem, it says that his hand is just as high as the hoop on this arcade basketball game. So there's our first equation. Now we're going to put in our second equation. And so our first equation is red on the graph, and our second equation is in blue on the graph. H of t equals negative 3t squared plus 1.3t. And our final equation is h of t equals negative 4t squared plus 2t. And it's the green parabola on our graph. So when I look at these three parabolas and I'm trying to figure out how much time it took each ball to go through the hoop, I find out that the blue parabola is going to cause me some problems. It looks like the red parabola crosses exactly at 0.3, 0. And it looks like the green parabola crosses at exactly 0.5, 0. but the blue parabola is somewhere in between 0.4 and 0.45. And if we were using graph paper, it would be very hard for us to estimate the right value of x, or the time in this problem. But since we're using technology, since we have the Desmos graphing calculator, we can just click on that x-intercept and it will tell us that that's 0.4333, 0. It says in the problem that the ball left the kid's hand when there was 0.38 seconds left on the clock. So if we look at the green parabola, it didn't reach height 0 for 0.5 seconds. So the game would have been over before the ball hit the sensor inside the hoop, and so that shot would not count. If we look at the blue parabola, it took 0.4333 seconds for the ball to hit the sensor inside the hoop. So time would have run out before that ball went in. And so the correct answer on our problem is the red parabola. That is the only ball that would have reached the sensor inside the hoop before the 0.38 seconds ran out on the clock. One way to think about it is this ball went through the hoop with 0.08 seconds to spare. That's how much time was left when he hit the shot that registered the high score on the game. At this point, you should have filled in parts 1 through 5 on your notes. Now, for part 6, how did the maximum height of the real final shot compare to the maximum heights of the other two choices? Well, to find the maximum height, what you need to do is just click on the parabola. So right now I'm going to click anywhere on the green parabola, and the key characteristics of the parabola will show up as gray dots. So there's a gray dot at the x-intercept here. There's a gray dot at the x-intercept here. There's a gray dot where the red and green parabolas intersect. And what we're looking for is the maximum height. So there's a gray dot at the very top of the parabola. And when I click on that gray dot, it tells me that the maximum height of the green parabola, or choice C, is 0.25 feet. Now if I go to the blue parabola, I can click anywhere on that blue parabola. And again, the key characteristics will show up, the x-intercepts, the point of intersection, but here's the maximum height. And I click on that gray dot and the maximum height is 0.1408 feet. And then I click on the red parabola and the key characteristics appear on the graph as gray dots. And when I click on the one at the very top, the maximum height of choice A, the red parabola, is 0.225 feet. So when you compare the heights from the one that went the highest to the one that went the lowest, it would go choice C, choice A, and then choice B. Part 7 says find the equation of another shot that could have gone in to reach the new high score while reaching a different maximum height. I think on this problem, if we're smart, we can find the answer by using intercept form. We know that one of our x-intercepts is going to be at 0. Right when the ball left the person's hand, time was 0 and height was 0. Then we know that the other x-intercept has to be less than 0.38 seconds. So as long as we have an x-intercept of 0 and an x-intercept that's less than 0.38, we will have a parabola that could have been a shot that could have gone in time to reach the high score. So I'm going to start out and I'm going to type in an equation in intercept form. My equation is h of t equals negative quantity t minus 0 times the quantity t minus 0.37. So the reason my a value is negative is I need my parabola to open down. The reason I have a t minus 0 is that will give me an x-intercept of 0. And the reason I have a t minus 0.37, that will give me an x-intercept of 0.37. This equation in intercept form gives us a parabola that shows us the ball will go in only 0.37 seconds, which is before the clock runs out, because remember we have 0.38 seconds for the ball to go in, and it meets the requirement of the problem because the maximum height of this parabola is only 0.0342 feet, and the parabola that we're comparing it to has a height of 0.225. So the problem asks us to find a shot that would go in time but have a different height, and this is one example of a shot that would meet those requirements. In summary, we solved this problem by making a graph that has time on the x-axis and height on the y-axis. Then we used the Desmos graphing calculator to graph all three of the given equations. We knew that we could find the answer, or we could choose the right equation out of the three that they gave us by looking at the time. The problem told us that there was only 0.38 seconds left on the clock when the ball left the kid's hands. So choice C, the green parabola, it took 0.5 seconds for the ball to go in. So the game would have ended before the ball went through the hoop. For the blue parabola, the ball also would have gone in after the game ended. So the only choice was choice A. That was the only parabola where it went through the hoop before the game would have ended. To find the key characteristics on each parabola, we can just click anywhere on that parabola and we can have gray dots that are highlighted. When we click on those gray dots, it will tell us the values at that place on the parabola. So that helps you to find the x-intercepts and the maximum heights and even the points where the parabolas intersect, which are not important for this problem, but it's another thing that the Desmos graphing calculator will tell you. Under what circumstances do you want to use the graphing method to solve a quadratic equation? Well, really, graph paper is not very useful. The circumstances are if you have access to technology. If you're using graph paper, many problems come up. The scale of the graph is not easy to change when you're using graph paper. If there are points on the parabola that you need to know the value of, but those points are not on lattice points, not right where the lines on the graph paper cross, it's difficult to find them. But if you're using technology, you can identify those points and find their values more easily. So again, the graphing method can work when you're looking for solutions to quadratic equations, but the graphing method is not the best method to use unless you have access to technology.